Alright guys, welcome back. Today we're going to do a quick video just overviewing Sinterit's PA11 ESD material specifically designed for electronics applications, especially in the automotive industry. PA11 ESD, as the name implies, is an electrostatic discharge safe version of PA11, better known as Nylon 11. Now this is the perfect material for anything near electrical components, housings for electronics or boards, etc. It is a fully ESD safe material, meaning it conducts static electricity away from sensitive parts. It's got a little bit better thermal properties than PA12 and really good dimensional stability, along with great mechanical properties, which Nylon 11 is well known for, and is biosourced from castor oil. Let me just give you the specs you're looking for right out of the gate. Its specific volume resistance is 1 times 10 to the 5th ohm, and its specific surface resistance is 5.3 times 10 to the 4th ohms. So let's talk about where you're actually going to see this material in industries. Really, we covered it: electronics casings, test fixtures for electronics, fixtures or for assembly of electronics, parts used in explosive atmosphere, fixtures for electrostatic dissipation, automotive parts, high accuracy parts. It's still got a lot of great detail capability and all that. What kind of machine do you actually need to print the filament? Just like all the other PA11s, this one does need to be printed with inert gas like nitrogen in the Lisa Pro, Lisa X, or NILS 480 machines because they have that inert gas capable chamber. What happens is, at the elevated temperature of the print chamber, the PA11s can oxidize, which affects their mechanical properties and even their surface finish. The nitrogen prevents that oxidation from happening, and it ensures better print properties in the end. By the way, if you're enjoying this breakdown, hit that like and subscribe. It lets me know that this content's valuable to you, and we've got a lot more coming. But for now, let's get into basic material specs. Right out the gate, you got a material refresh ratio of 60%. A bit lower than the others. You'll have to add a little bit more new powder than old powder, but it can still be reused consistently. It's got a shore hardness of about D76, so it's very rigid and hard. The melting point's around 204 Celsius, and the heat deflection, or the softening temperature, is around 103 Celsius. Again, the volume resistance is 1 times 10 to the 5th, and the surface resistance is 5.3 times 10 to the 4th. Let's get a little bit into the strength specs. It's got a tensile strength of 46 to 50 MPa. It was tested on virgin powder, brand new stuff. Tensile modulus of 1850 MPa, a flexural strength of 56 MPa, and a flexural modulus of 1240. It's also got an impact strength using the Sharpie method unnotched of 59 kilojoules per meter squared, and an elongation at break of 27%. Now, all this info, all this data is available on the technical data sheet, so definitely check out visionmatter.com/Sinterit for the links to all of those. Okay, so now let's check out some example parts. The best one I got here on hand right now is this little electronics enclosure. Now inside here we've got a little Wi-Fi module and then some connector pins and everything else like this, but this is basically going to prevent, oh yep, the whole thing opens up like that. Printed in one part. It's pretty slick, so it's like a hot swappable. Oh, can I take this out? Yep. I can take this whole thing out. So here you go. That's the little antenna there. But just to keep static electricity from, or other stuff from affecting this, it's an effective material because it'll take that electricity and dissipate it throughout before it gets to the actual electronics. Cool little thing. I know you guys have a lot more examples and ideas of where this could be used, so let me know down in the comments below where you would use it. And I'm going to pull up some case studies and some other images and sort of go through what the possibilities are. Again, we've got the connector parts, which would be great for this type of thing. If you need ESD safety in a connector like this, that was a great use case. Let's see, electronics enclosures, obviously, like the Raspberry Pi case we saw earlier. Definitely a very pertinent application. Robot gripper arms and things of that nature. I think this would be huge in semiconductor manufacturing for that type of thing because they use robots to move silicon wafers around and things of that nature. So just eliminating the, any static discharge and whatnot from that environment, this would come in very, very handy, especially if you're making totally custom end effectors, which is just a fancy arm for gripper or something like that. If you're making them totally custom for whatever your application is, do them on here and you don't have to worry about the whole electrical danger part. So what would you guys like to print on the Lisa on any of these materials? What would you use it for in your business? Just reach out if you want and send us a 3D file, and we can actually give you a breakdown on our ROI. How many you can print in one build, how long that'll take, how much electricity it'll take, how much machine depreciation will occur during that time, and all the other factors to get you an actual price per part and see how well this will actually work for your business application. You've got questions, I'm sure, and we've got answers, so leave a comment down below, shoot us an email, or give us a call, and make sure you subscribe for more content. We've got a ton of videos out there. We're going to have some more full comparisons, and we sell entire systems for high-temp FDM like Peak and Ultim, 3D scanners, 3D scanning, and now, of course, SLS printing. So we're here to help. Just reach out, and we'll answer all your questions. Thanks so much for watching. Have a positive rest of your day, and I'll see you on the next video.